All right. Sorry, I got, got talking and come back about 5 minutes late here, but we don't need this anymore. Maybe I'll just minimize it. And I'm going to create a blank map for ArcGIS. So I got a blank map for ArcGIS. I'm going to load the data in. I'm going to talk about what we're going to do, and then we're going to do it. And there's going to be quite a few buttons to press, but a lot of them will be similar at some point. So from then on, I will leave it up to you to finish it. Let me bring it up and show you what we need to do. So if you go to the data, what I want you to load are all the layers that start with risk. And eventually, these two as well. 1, 2, 3, 4, 5, 6, 7. Got 7 risk layers. Eventually, we're going to need polygon habitats and watershed as well, and protected area. But those would be kind of like visual overlay layers. So let's add each of those in. I'm going to add all the risks, and then I'm going to add watershed, protected areas, and polygon habitats. Add all those in. And when you add yours in, they may come up as different colors than when I add mine in. Okay, yeah, So you don't need planting units, you don't need point species or line habitat. All right, ready? Everybody ready? I'm gonna hit add. Okay. So, got a lot of stuff up there right now, and yours may look at different colors. Is yours different colors? All right, that's okay. ArcGIS, I don't know what random color generator they use. It always looks kind of pastel colors to me, but they're going to be different. Okay. And so what shows up as purple on my screen, the largest polygon is a watershed boundary in Jamaica. That's what that is. The lines that you see are roads. The dots that you see are towns and quarries. Yeah, they pick up rocks. Maybe the attributes say what they do, but I don't think so. Jamaica is I'm sure that they could be just quarries for rocks in general. For building roads and stuff like that. It looks like one of them is for limestone and one of them is for river aggregate. These are quarries. And then Jamaica is also I'll turn off those two for a second. We got roads. That's pretty easy, self-explanatory what roads are for. Okay. Small scale agriculture is basically farmers doing their thing, but not on a wide scale where they're, you drive through Iowa, you'd be driving for 30 minutes and be on the same plot of somebody's large scale agriculture. This is like small scale agriculture. And then sugarcane. Sugarcane is more of a large scale crop. There's one plot of sugarcane in the middle of our watershed. And then there's this other layer called bauxite mines. There's only a single bauxite mine. Anybody know what bauxite is? The element. The bauxite is used to create what? Bauxite ore. Nobody else. It's not really important to this song. It's as they would say in Jamaica, well, it's aluminum. They pronounce it aluminium. Well, I'm sure that they don't have any more Jamaican accent to that. But what's that? Yeah, British way of saying it. And you know, it's a former British colony. But I can't do a Jamaican accent. But that's aluminum. That's what they're getting the raw materials for aluminum, basically, right there. Right, so it's a pretty intense activity. Urban areas. There's an urban area off to the just out of the watershed. So there's a large settlement just off the camera there. I'm trying to figure out which one it was, but I'm pretty sure this doesn't overlay with other data. Okay, but anyway, there's a larger urban settlement that's going over, and I think that's all the risks. Okay, so each of these risks are like negative forces for what we're trying to do. We want to cite a new protected area within this watershed. So that's our goal here. Here's the existing protected areas. I'm going to move that up to the top to kind of overlay everything. And we're not really concerned with the existing protected areas yet. First, we just want to make a map of suitability for protected area, and then come up with a good area. So we have a few things to consider, and today we're only going to make the suitability portion of the map. Okay? Ideally, at the end, we want to know where the existing protected areas, which are shown here, and we would want to know where the habitats are that we're trying to protect. So these areas here represent the critical habitats that are areas that would be under the highest concern to set aside. And it's not a mistake that these are actually correlated with areas that there's very little human activity right now. I mean, you can see that there's less activity going on right here, although there is this large sugarcane field than there is like in this area. Okay, there's no habitat over here, but there's a whole lot of roads and a fair bit of sound over in that area. All right, so I only included those layers because we might later throw those in and consider those as additional steps. Right now, we're basically only concerned with the layers that have the risk in front of them. We're going to create a map of suitability. It'll be considered negative suitability, the opposite of suitability. And that is, we're going to use some attributes that are in all of these data. And there's two fields that we're going to be concerned with. I'm simplifying this process a bit. Initially, there were negative factors associated with the freshwater species that they were trying to look at, and with the terrestrial species. We're only going to deal with this terrestrial intensity number, not with any of the other numbers. We've got the terrestrial intensity number and the terrestrial, what we call, it used to say terrestrial distance. In other words, what that is the distance at which this negative feature stops having any effect. Okay? And so the way I've written this lab up is that if you're inside the feature, in other words, if it's a polygon feature, if you're inside the feature, the entire terrestrial intensity applies. The terrestrial intensity is basically what from the lecture?
Over.
What's that? We're actually not doing a pass-fail screening. I originally had the idea to do weighted linear combination, but then I realized that I'd set all the weights to 1, just for class, and I was going to go change them all, but I didn't have a chance. All the weights are 1, and if we take the factor score and we multiply them by the weights and add them all up, and they're all 1, we might as well not use the weights, right? So we're actually going to end up doing basically adding them all up as the as the factor score, the overall factor score. And so I guess what I'm trying to say is this field right here is going to represent the rating. Okay, so this is the rating, and this would have been the weight. Okay, and so if you wanted to experiment, you could do that. I'll actually show that when we go ahead and do the overlay. So this field represents the rating. This field represents the weight, and this field represents some measure of proximity. In other words, if you are, the way I work the lab is, if you're within half of this distance, the full terrestrial distance, full terrestrial intensity applied. If you're beyond that, only half of the weight applies. And then if you're beyond the total distance, the weight doesn't apply at all. So let me say this better. You all see me on the coast? You guys can't, you won't be able to see this on video. But if I was standing inside of a limestone quarry, right there, the intensity would be what? 40, right? Now, if I'm within 250 meters away, it's also going to be 40. That's what I'm trying to say, okay? Half of the distance. If I'm 250 to 500 meters away, half the intensity. What would the intensity be? 20, right? Okay? Now, if I'm outside of that, no intensity. So that's the way we're going to do it. And we could make it more complicated, which is the way we originally did it, and just had kind of a multiple ring buffer, stepped it down. All right. So that's the way that we're going to do it now. And then we need to overlay everything at the end in order to come up with our suitability map. And after we overlay them all, we need to create a new field called score and then add them all up. All right. Now there's one thing that I didn't talk about in the lab and that I want to talk about now. What happens if there is a limestone quarry that is 250 meters away from a river aggregate quarry, or 10 meters away from a river aggregate quarry? How should we handle it, is what I'm trying to ask. Should we add them together? That sounds like a valid way to do it. It's probably the easiest way to do it. That's the way we're going to do it today. But you might want to think about that question. If you were to do this differently, would you want it to be different? In other words, if there was an area where let's just say there's towns. There's two towns like this, and they overlap. Should that overlapped area have twice the intensity or not? Okay. So today we're going to say yes, they should have twice the intensity. But in the future, you might not want that. All right. Okay. So let's go ahead and do this. So we're going to do the same thing basically for every single one. For every single layer, what are we going to do first? It's the operation that's going to tell us how far away we are from something. Right. So we're going to do the buffer for each one of these layers. And today, for the lab, for demonstration purposes, I'm just going to pick two, and then you'll have to continue it and do all of it. Okay? Does anybody have any preference? We should probably pick two that will actually overlap, because then when we do an overlay, it'll make sense. So maybe two that cover most of the area, like towns and roads cover most of the entire area. So those might be good candidates. All right, so we'll do towns and roads. Only the risks, because only the risks have these attributes that contribute to intensity. All right. So what I'm going to do is choose to buffer. I'm going to choose the buffer tool. I'm going to run the buffer tool a little bit different. Okay, I'll show you how we're going to do that. So let's choose towns first. Right. Now this time I've just been selecting OK here because I don't really care where it's stored. But now that I'm working through this, it might be useful to kind of store this data in the same location we've been working. I'm going to choose the location that I've been working in, which is now C temp proximity, analysis tool proximity. And I'll leave this up for a little while before I hit OK. So I'm going to save that back in Ty Dixon, but I'm going to create a whole new folder called output. And one thing that I'm going to do inside of output, shapefile, like I said, this data is 7 years old. And this file format that's more often used now, called a file geodatabase, wasn't created. I'm going to save all my results in a file geodatabase, just to be more modern. I could save it as a shapefile, but then I'd always have to remember to put .shp on everything. So I'm going to hit new file geodatabase, and I'm just going to call this, maybe I should have just put this in the layer above, but I'll call this outputs.gdb. And finally, inside of that, I'll save this as risk underscore towns underscore buffer. Okay. So the location will be different on my disk, but I saved it in the same folder that I unzipped the file in. Then I created a folder called output, which after I did it, maybe that's what I did. And then I created a file geodatabase file. This button right here, the little canister. Okay. And then I named it outputs. That's why I think that's redundant. But I've already done it. So. And then finally, I named it the exact same thing as risks towns buffer. I named it the exact same thing, but I appended the word buffer on the end. And again, not that you have to do it, but there are situations where spaces freak out on GIS, and so I put underscores in there as it's one of my best practices. Okay. So for the distance, instead of choosing a linear unit, I'm going to tell it to use a field. And what that will do is it will allow me to use that buffer field that's already present. Remember, there's a field called TERRA underscore dista, right? The reason why it's called underscore dista is not because dista is a Jamaican word for distance. It's because, anybody know why it's truncated? So a shapefile doesn't allow a field name that's over 13 characters, but a geodatabase will. Another reason why I like using the geodatabase is better. So I'm going to change this to field and choose as my field terrestrial dista. So now, remember, what was terrestrial dista? Yeah, it was what? No, you're thinking about the intensity, which is fine. But the terrestrial dista is 500 exactly. Okay. I'm gonna run that. Well, for all of these, it's the same. So we could just put 500, but I'm not sure it's the same for all of them. It'll append .shp on it, it'll save it as a shapefile, but no, it's not a big issue. It'll save it as a different format. It'll still work. Your field names will look different because they'll all be truncated at 13 characters. Yeah. Yeah, I'm pretty sure, and this is actually going to be helpful. I'm pretty sure that each of these, let me make sure before I say this. An attribute table, those are all 500. These are, no, see this one changes. It's 100, 200, 150, 200. I forgot to actually do something. I forgot a step. Okay, but this is okay. Oh, do you want me to bring that back up? Bring that back up. I forgot to do something. I need another column that is half my terrestrial distance. Okay. Well, I jumped the gun, but we'll do this first, and then I'm going to do that. So everything else is the default, and I'm gonna keep everything else the default. Okay. 500 meters. So the units that this is in is meters. So this is a projection that's in meters. And actually, now that I think about it for a second, if I don't go back and do this step that I forgot, that the output won't have the number that I need in the output. So we're going to have to. No, it'll be fine. It'll be fine. So we're gonna leave it out, and we're gonna hit OK. Yeah. In fact, we never need to do anything beforehand. I've got a better way to do it. Okay. So let's say OK. Everybody hit OK yet? Okay, good.
Did you make a change?
No. So it runs through, and it has the buffers. Oh, they are different sizes? Which one did I do for towns? Did I do for towns? Yeah. Okay, so yeah, for this one they are. So, oh yeah, I was talking about quarries, and those were all 500. But these are different, yep. So my guess, not my guess, the towns are basically different as determined by their population. So here we see these towns and now they're buffers, and they're different sizes. All right. So the part that I said that I skipped, and we can go back and do again, is that now we need to buffer them at half of their size. Unfortunately, there's no easy way to do that other than create another field called half distance. Okay. So we've done this before, right? We've added fields. There's two ways to add a field. You can go in here, or sorry, we're going to go back to the towns layer. So we can go in here and we can add another field by just opening up the table, which was right click and say open attribute table, and then saying add field. That's probably the easiest way to do it, the quickest way to do it. But remember, I told you there's also a toolbox way. So when we get to the point where we start creating these things, we'll want to do it the toolbox way. But if you just want to get it done quickly, the easiest way to do it is to just say add field. Right? Now, we're going to call this, half dist or something, just to be consistent. And basically, it's just going to be half of the distance value. This is what it's going to store. Now, a short integer may not be enough to hold half of a big number like 1,000, so this is 500. No, it will be. I'm thinking of a byte. Now, I don't know if there's any distances which would result in numbers that would be decimal places. Probably not, though. I think they'll all end in 0. It'll probably be fine leaving it as a short integer. But let's say we had a distance of 7. Okay, we wanted to calculate half of that. we would want to change this to floating point. Make sense? But we're fine leaving this short integer, which will be a number. The power of 2 that's up there, I think it's, I hope it's not 255. I think that's called a byte, which isn't on there even. So I'm going to leave it a short integer and just hit OK. Okay. And then, again, there's a tool for doing this next part called calculate field. We've done it before. We've used it. But there's a quick way to do it. If you go over to the field and right-click on it and say field calculator. Right-click, and then just say yes here. Now, by default, it wants it in VB script. We're going to do a very simple calculation, so it actually doesn't really matter which one you choose. You can choose Python if you want. I'm going to leave it a VB script. All I'm going to do is double-click on terrestrial distance, and then click on divided by, and then enter the number 2. So double-click on dista, divided by, oh, I choose the wrong dista. Terrestrial dista, divided by 2. And if you've chosen Python, the only difference is it would have put in exclamation points to delineate the field. All right. So once I hit OK here, it's going to go through and calculate half the distance for all those fields. Let's just verify that I did that correctly. What's half of 100? 50. Yep. And it looks like I did it right? There might have been some distances that were 75, but don't worry about it, because it'll still calculate and it'll just round it. But what's half of 75? Yeah, 38. Oh, was there some 75s?
No.
Oh, okay.
No.
So we're fine. Okay, so now we have half distance, and we need to do this again. We need to go run the, I'm going to close this. We need to go run the buffer one more time. We go to results, and we go to our current session. We can rerun the buffer tool. And what we can do is open it up, or you can open up the buffer tool the same way. But what I would do is go to change the field to half dista and change the wrist towns buffer and call it wrist towns buffer half. I'll leave that up there for a second. And when we run this, we'll have the exact same thing, but the buffers will be smaller by half.
My buffer, like, it keeps coming up error every time I do it.
Okay, I'll come look. I'm gonna hit OK here, and then I'll come look at yours. Then you can see these little half buffer guys. Right? Is anybody else getting an error when they try to run the buffer?
I think this is more cool. This is one.
Okay. For some reason, on your computer, and I'll have to investigate this later, it's not allowing processes to run in the background. But those are going to run really fast like that, it doesn't matter. So background processing is nice because if you have process going for 5 minutes, you can still interact with ArcGIS. I just turned it off because of that error that background sort of doing something. But now it's doing things. Now it's doing it in the foreground. So basically, it's not going to allow you to click anything, and that window's going to come up, and you'll have to exit out at the time. It should work.
I tried to smaller so that
Okay.
not sure if they were, but
That's pretty small.
yeah, it's weird. And then I tried to go back and go back to Cooper.
Okay. So go back to features, and then now change it. Now hit OK there.
Oh, okay.
So what you did when you went down, I didn't see which one you selected. I think one graduated symbols. So you told it this is how big I want my dot to be. The smallest I want my dot to be, but you never told it how to symbolize it. So you can tell it to symbolize it by population density. But until you select one of those, yeah, there's none. So like,
But it can just like Jesus. People should have it out there.
it kind of makes sense, but that's not the way ArcGIS is doing. So it won't fill this table out until you select one. So if you chose population density, now it'll symbolize it by population density. Or it doesn't select it. I mean, if you really wanted to symbolize it, so it could be population density, normalized by population density. You don't have one value. Okay. Which is,
Features.
yeah, change that to what you want. All right, so we have our two buffers. One represents the intensity, our intensity values here, which need to be the raw intensity value. And then the value here needs to be 1/2 the intensity value. And in my head earlier, I said something like, "Oh, we need to go back." And what I was thinking is that we need to calculate half the intensity value as well. We don't have to because we can just include that in the formula later. Okay, well when you calculate that. And okay, so the next thing that we need to do is to make our factor score layer, our overall factor score layer, because right now we have two separate layers. We need our town's factor score layer. We need to create that, okay? And so we need to create our town's factor score layer by overlaying these two layers. And that will result in our town's factor score layer. And then we need to manipulate the attributes a little bit after we do that. But that's the step that we're on. So if we go back to our toolbox, what can we do to make one layer out of these two layers? What's that? Yes, we could do a union. A union will work just fine. Whatever we choose, we're gonna have to do some we're going to do some manipulation. Could we choose an intersect in this case? No. Why couldn't we choose an intersect in this case? Right, it would only show us the areas within that half buffer and not the areas in the whole area. Is there any other tool that would work? I don't know if Space and Join doesn't ever do the dynamic segmenting of the lines. We need basically the big circle to be, and the little circle to be burned into the big circle. That's not going to work. What's that? Dissolve. Well, dissolve only works on one layer at a time. What about, just really quickly, what did identity do? Identity. Okay, so what if we made the larger circle the primary one? Would identity work in this case? It would. And the reason why it would work is because the smaller circles, just by definition, don't exist anywhere except for inside the larger circles. So in this case, because of the layer that we've created, this is really academic work, but it's useful to learn about because then you'll understand more about what each of these tools does. In this case, identity and union do the exact same thing. There's actually no difference in what they do. And it's only because of the way that the features exist on the map. Okay? There's no difference between what they do. They all combine all the attribute features. And because, in this case, this little yellow one, all of those little yellow ones, if they were inside, they'll do the exact same thing. And that's not always the case, but in this case it is. All right. So it doesn't really matter to me which one we pick, but let's do union because that one makes a little more sense. Because union would work in all cases, whereas in just this case, identity would also work. All right, so I'm going to choose the buffer and the buffer half. Okay. All right, and then I'm going to save this, and I'm going to save this as risk towns, what do I call that, factor score, or factor rating. Not the score is the overall. Risk towns factor rating. So for each one of the operations, you're going to have run all three of these. We're going to say all. We want to have all of the attributes joined over. All right, and that's all we need to do. So all we need to change is the two inputs and the town's factor rating. Make sure this says all, and we're all good. Does that make sense? Everybody get that? I'm going to hit OK. And when I open this attribute table, now I have a value for each of these. And you'll notice it does get kind of busy. There's a field called terrestrial intensity and a field called terrestrial distance. And now there's some other fields called terrestrial intensity and terrestrial distance, but they're 0. Okay? And there's some that have -1s and 1s. Okay, there's a lot of different fields that give us the information we want. And what's the information that we want here? What do we need? What do we need to do with the data that's in this layer? I'll give you a hint. We need to create a new field that's going to have the rating value in it. Well, how are we determining, according to my definition, the intensity for the inner circle? No, it's fine. So the inner circle has the full intensity. and the outer circle has half the intensity. So what we need to do is select all the areas that are inner circles, assign them a value for the score, select all the areas for the outer circles, and assign them a score, and we'll be good, right? Okay, so let's open up the table again. And what we want to do is create another field. And our field is going to be the score. And because in the end, when we do the final union between all of the factor scores, we want the fields to all have a different name so they make sense in our mind. So the new field that we're going to create is going to be called, let's just call it town rating. Town rating. We're going to create a new field called town rating. And again, we're just going to get integer values because we only have integer values for our intensities. So I'm going to click here and say add field, and I'm going to add the field I'm going to add is called town underscore rating, and leave all the rest of it blank. Okay. And now I have to look for a field in here that's going to help me. What I could do is just copy all the terrestrial intensities over, right? Well, but that wouldn't, I need half the intensity values. I got 5s of them. Maybe I should have done float. Yeah, let's do that real quick. So go back to your town rating, right click on it and say delete field. And then just recreate it. We're going to add a field and call it town rating and make it a float. And this will allow us to make it a number that has a decimal. Because 5 divided by 2 is 2.5. All right, now we did that. Okay, so we've got our town rating. We're going to find a field over here that will allow us to know whether or not the town rating needs to be the full intensity value or half the intensity value. So let's look through the fields and see if there's a field that will help us to do that. If anybody has a suggestion.
That's why you just cluster have. All the negative ones are the areas that are not they're not within both polygons.
Right. So the negative ones are areas that
They're outside the half distance.
outside of the half distance, right? So if it has a -1, what do we have to do to the intensity value? Half it, exactly. The intensity value needs to be half in those areas. And it can be the full intensity value if it's greater than -1. Okay? So we could write a little code snippet, certainly like we did with the other one. But since there's so few values in each of these, it works really well to just select them. And we can select them manually by just right-clicking here and sorting them and selecting them. That works. So I just selected all of the negative ones manually. Or I could just go up to selection and say select by attributes and say, okay, I want the factor ratings where this field is less than 0, which would be the same thing. So nothing changed because it was the exact same. All right, I did that a little bit fast. Anybody? So which one? Okay, select by attributes. And then I put this in. So this is the field that we're messing with. It's a big long field name. It's FID underscore risk underscore counts. Selected from here though, because if you save it as a shape, I'll have different names. And then is less than 0. less than 0 is going to choose all the -1 values, right? I could, but I didn't prepare for it. So I'd have to punch it out a few times. But it'd probably be the way that I would do it if I built a model in the model builder. Because it allows you to do it all in one tool. You just run calculate field once. But here we're going to run calculate field twice. So I have these selected, and if I run calculate field, it'll only operate on the selected records, if any are selected. So that's why it's always important to clear your selection, unless you know that you're operating only on selected values. Okay, so if I right click on this guy and run field calculator, say yes. Here, I'm going to choose the sorry, what am I going to do here? Maybe I should just ask that. Terrestrial intensity divided by 2, exactly. So here, terrestrial density divided by 2 is going to be what I do. I click OK, it'll run through. It can show the code block. But my code block would involve saying, if FID risk found buffer less than -1, do this. Else, just use terrestrial intensity.
We created count range, so I got zeros instead of null values.
Okay, that's fine. Because we're going to replace all the values anyway. So if anybody has zeros instead of null values, probably just a difference in.
After I run it, I get zeros.
You get zeros everywhere, or just some zeros?
Yeah, I get zeros.
Let's go look at terrestrial intensity. Oh, there it is. Right click on this guy. Save properties. Oh, okay. Yeah, go back. Choose the other one. Yeah, there are two, because we did an overlay, there are two different terrestrial intensity fields. It makes it confusing. So make sure you choose the second one. So run it again, right click. Field calculator, yes. Delete that. You chose this terrestrial intensity right there? Okay, so this time to now, choose this up. Terrestrial intensity. It's called terrestrial intensity _1. Did you see that? Okay, so. Okay, so I'll explain that. All right. So originally, these risk town buffers and the risk towns buffer half came from two different, it came from the exact same data set, right? And they both had a field called terrestrial intensity. Both of those data sets had terrestrial intensity. So when you do the overlay, all the attributes carry through. And what ArcGIS does for your display purposes, I'll show you this, is that it, I want the factor rating more. For display purposes, fields, that's what I want. For display purposes, it allows both of these to be called the same thing for display purposes because they have the same name. But if I click on them, it will show that they actually have different names. This one retains the original name, and this one gets called _1. The actual field name for this one that's highlighted is _1. Okay, can anybody guess as to which one gets named _1 and which one doesn't? I don't know for sure. My guess is that it's the first one in the list when you did the union is the one that doesn't get the _1, and the second one gets the _1. And so that's why there were a few students who might have unioned them in the other order. And so that's why they had to choose _1 instead of choosing that in order to get the number. Did you get all zeros too? Oh, when you did 1, you got all zeros. So you were like me. I did the ones that weren't all ones.
You don't want all zeros.
You don't want all zeros here. All right. So as long as you don't have all zeros, you're good to go. If you have all zeros, no. And let me know. But I think we got it all cleared up. Okay. So the next step is to calculate the values of the rest of these. Now, there's an easy way to do this. If you just go under selection, or sorry, no, it's under there. It looks like it's right here. This button right there says switch selection. And I'll just switch the selection to the opposite.
It's already purple, so undoubtedly it already got sent out.
What are you talking about?
So now you can do that again.
Look at the desk.
Right click on town rating, and this time you're going to choose
To the email they sent you.
just the terrestrial intensity. You're not going to divide it by 2.
Publish.
Because I already had hyperlinks purple. But then I went through the process all over
Right,
again.
and this is everything in the smaller area.
I didn't mean for you to be so
The
literal.
higher intensity in the smaller area.
Oh, you told me
So is it okay?
exactly that. And it's going to
Sorry, go ahead.
You don't want to cut it.
No, I don't want to divide that because this one got divided by 2 because these are the circles that are inside the smaller circles. Sorry, opposite what you said. These are the smaller ones. These are the larger ones. Let's verify that actually. So I'm gonna close this out, and I should be highlighting
Video feed them.
the smaller circles, the ones with full intensity. Full intensity there.
Well, yeah.
And this is the half intensity area. If I click right here,
trouble sleeping.
I get half intensity. That's a town rating of 35. Here I should have full intensity, which would be 35 times 2, 70.
What you been thinking about all of
35, 70. 35, 70.
Working.
All right. At this point, I might, because the more we do overlays, we're going to magnify and keep magnifying the number of
Does it have how often does it have?
fields. So I might go and delete some of the fields. Yeah.
I know you got to figure out how to close the door because Jack wakes me up in the middle of the night. I don't know about
Let me figure out. That's not hard to figure out.
What?
Use the same one that you used before.
I do it close.
The same one that worked before, use again. Because if you use the other one, it's just all zeros. I want it to carry through. It's a good question.
Clear that up.
All right. So this is one case where I think the toolbox version is actually easier than the GUI version. Because you could come in here, you could open this up, and you can actually eliminate these by right-clicking and saying delete field, right-clicking and saying delete field. That gets old fast. So there is, under data management tools and fields, there's one called delete field, and it does say delete field, but it should actually be called delete field.
You need to
Fields at the same time.
ride your bike or
Risk
something,
towns factor rating.
so that way you'll be burning up some in.
You can choose that, and this is one example of a tool that operates in place. It does not produce an output.
You said
It
the
modifies the input.
one does or whatever it's called.
So when you do this,
$10 a month.
be careful that you're not getting rid of the fields that you don't want.
I think the open 24.
So, like I said, we don't really need weight anymore. I'm going to leave it there just to show you that later when we multiply them all by the weight.
Roger.
But, we don't really need any of the other fields at all.
I mean, I can do that, but I'm going to buy some stuff forward.
Well,
Yeah.
you gotta go
Accidentally click one and this one.
do it.
Okay.
whenever you get off of work,
Undo button.
There's no undo button.
because you're already dirty from work.
Don't do that. Yeah.
of want somebody to go with it. I don't know like what you said.
Right. Okay. There is actually an undo button, but ArcGIS, I mean, ArcMap is a tool for like making maps. So let's say you colored something a certain color, it would undo that. If you change anything about the symbology, it would do that. But it works much more like a real transactional database when you actually go to edit data. So there's no undo button in the data, with the exception of manually editing features, which we don't cover in this class. But like, let's say that you wanted to come in here, and you actually wanted to move this line from here over to here. You can start what we call an edit session, and you can move that line over, and you can undo that too. As soon as you say stop editing, you've lost your ability to undo. But as long as you're still in that edit session, you can undo. There are a lot less things you can undo in ArcGIS. Just like with a real so yeah, you don't want to do it without. So you could actually do this operation later. You don't need to drop all these fields. I just think that it'll make it that easier, more straightforward if we do get rid of the fields. So I'm going to leave weight. Sorry, I said I was going to leave weight on there, but all the other fields I'm going to get rid of, except for the town rating. That's the only really one that I need. Okay. However, if your town rating doesn't look right, if you haven't calculated it right, and you delete all these fields, there's no way to go back and make it right at this point. So. Yes. Yeah. Don't delete them right now if you don't want to. Well, actually, nobody has to delete a RAM. Just don't delete it because it won't really matter. I'm gonna hit OK. I have confidence. All right, so I'm just going to show you what it looks like and why it's simple. Okay, so I get rid of everything. I still have weight. I still have the town rating. Now, this information about the length and the area of the feature is actually always in there. I mean, it's in this. It's stored in this shape area because we can access it. But if it's stored as a database, a geodatabase, it will calculate these for you and show them to you. Just on the fly. It's doing it on the fly. If it's stored as a save file, it doesn't do this. It doesn't have that ability to kind of calculate those areas on. You can manually request it. That's why these fields will always be in there if you have a geodatabase. If you have a shapefile, the only fields that will always be there are object and shape. And actually, object ID won't even always be called object. Sometimes object ID is called FID, sometimes it's called object ID. There's a few other things that could be called. Shape is almost, in ArcGIS, is almost always shape. And then these are two fields that will always be there if it's a geodatabase. So there's a minimum of 2 fields, sometimes 4 fields. And then these are our fields that we just didn't drop. Weight and town rating. But again, you don't have to do that. As long as you still have the town rating field, you're good.
A lot of different FIDs, and I have no idea where that comes from. Where does that come from?
So in ArcGIS, FID stands for feature ID. I don't know. And so one way to think about these are features. We talked about that. Features. Another way to refer to them as objects. Entities. I've never seen entity ID, but. And you can't change those values. It's automatic. Those numbers are automatically generated. All right, so we have to do this again, but with roads. And so we did it all with circles. Now we're going to do it with roads. And it'll be a little bit faster now that we've done it before. But I'm going to clear my selections. Okay. So remember that the process was to buffer them once, buffer them half, and then union those together, and finally to reinside the intensities over. That's what we want to do this time again. All right. So we might as well do it for each of the rest of them. I think it'd be conceptually easier to first calculate those half buffers, then do the 2 buffers next to each other. So let's do it in that order. So the process, if we were to write it out, it would say calculate half buffer field, buffer half, buffer full, union, reassign new value. Or to write it out. So I'm going to do that first. So go into the roads, open up the attribute table, and the first step is to create the half buffers, which is add field one, or sorry, I call it half dista. And then this is going to be a float. Say OK. Calculate half of the terrestrial distance. So terrestrial distance divided by 2. All right. All my terrestrial distances are divided by 2. And so what's the next step? Yeah, we buffer. All right, proximity, buffer. And we're going to do buffer twice. The first time that we're going to do the buffer, and the second time we're going to use the same input features. What's the input feature they're going to be this time? Roads, yep. So we're going to choose our roads, and then we're going to say risk roads buffer, and choose as a field. So, sorry, did you have a question?
Yeah, when I did the calculation for half this, I got all zeros. That is an error, right?
Yeah, that's an error. Okay, what field are we going to choose here? We're going to fix that error for
Terrestrial distance.
yeah, terrestrial distance.
I don't know what was there before, but then was I supposed to do that
Oh,
calculation
so this
somewhere
is
else?
half dist divided by 2. So you're taking this field that's already zeros, you're dividing by 2, so
Oh,
it's 0.
okay.
You need terrestrial.
Okay, how do I undo that? Oh, it doesn't matter if I undo it. So I don't do the calculation.
No,
or-
you need to do it on this field. I'll show you what's wrong.
Oh, okay.
This is what's wrong.
And it should be this.
Yeah, terrestrial. Do you see why it's?
Yes, I don't understand that. Thank you.
Is there a way on this? No, I can't. Is there a way to like make some yeah.
Yeah, it works a lot like a database. You have to drop the field and then add it back. I'm sorry. Okay, so now we have our field. You're right. We're going to choose the terrestrial distance as the distance. All right. So we can leave the rest of this the same. And yeah, the rest of all of these will be the same. And say okay. Let's go ahead and look at it real quick. So now we have these roads, and if you look at the roads, it's kind of cool that we've got some roads that are bigger than others. See what I'm saying? And again, now we are going to have areas where we have road intersections, we have multiple intensities, which again, we could say, I only want the smallest one, or I only want the largest one, which might be valid, but I only want the largest intensity at the intersection of a road. So maybe when we go to do the union, I'll talk about strategies for how we could do it differently. All right, so we've got our roads buffer. Now we need to do our roads buffer half. So I like to just go into results, choose the last buffer we did. I'm going to change this to _half and change terrestrial distance to half dista. I'll leave that up for a second.
Creating a new layer, or we just write another one?
No, this is going to make it so that it creates a new layer. See how I'm _half? See that? Okay. Okay, I'm going to run this now. Okay, and when I do that, I've now got the two buffers that I need, the small buffer and the large buffer. That represent those areas that are half and those areas that are not. So the next step after that is to union those two layers together. All right. Oh, okay, so under overlay, it's under overlay union. So there is a tool called union coverage, and we don't have coverages. Coverages are that old data format that I referred to that actually enforces two-dimensional planar geometry, and we're not using that particular form right now. So we're going to go under analysis tools, overlay union, and choose that one. Okay, so our input features are going to be what? Right. Okay, and then we just renamed this to be the factor score, right? The factor rating. Factor rating, but this is going to be called roads factor rating. Want all of them. That's fine. Okay. So then we hit OK. And then it'll run through and it'll create our factor rating. All right, now this is where we kind of depart from. We can do the simple thing where we're going to basically treat these all as separate layers and kind of magnify their influence. Okay, we could do that one. And if we did that, we could just proceed exactly as we've already done. In other words, we can open up the attribute table here, and this is what we're going to do. We can find all of those that are within a smaller area and leave those intensities the same, and the larger area, we're going to take those intensities and divide them by 2, okay? But if we wanted to make it so that all of the overlapping areas only got the maximum intensity, what could we do? Well, it might be kind of complicated, but we could use a maximum function. And a maximum function but you're right, so there's a maximum function, but what tool? And it's actually a tool we've already used, but it might be obscure as to why we'd use it. So we could use the dissolve tool in this case to do that. Dissolve does have a maximum function. So if we went over to, I think that's under, that's in, where is dissolve? It's under feature class. No, I gotta search for it because I'm not top of my head. I'm airbrained sometimes. I typed in search in the search menu. Okay, it's under data management generalization, dissolve. Okay. So what dissolve does is that it takes features that have a common attribute and it changes the boundaries so that any similar boundaries will be removed, including the fact is if they're overlaid on top of each other. If they're overlaid, if they're the same spatial boundary here, or a subset of the spatial boundary, as long as they have the same attribute, or combine them. And one of the things that allow us to do is combine them based on something like, well, we have to actually give it a field first. So we would do this on the Rhodes factor rating, and we could take the intensity and say we only wanted to have the min, the max, the largest value. Okay. Why is that?
It doesn't matter if you're on the full buffer, your intensity value is still in this. Because we never pulled it.
Right. Yeah. So we have to first calculate these factor rating scores and then actually dissolve on the factor score, right?
Right. We can't do it.
Right. Okay, so let's do the first thing first. Let's open up the factor rating score. And again, we have this field called FID, Rhodes risk buffer half. And that field is going to help us determine whether or not we're going to half the thing or not. Okay? Negative ones mean we're going to half it, right? Oh. I don't know when I pointed to, I did say, no, you're wrong. And I was like,
We dissolve them on the basis of that column. So if they're Rhodes risk, FID risk Rhodes buffer half is -1.
right now, at this point, yeah. Yeah, we could dissolve them right now based on that -1, and that would actually make the data set a lot. Well, but we'd have to dissolve them on -1 and on intensity. Because if we didn't say intensity 2, the intensity value wouldn't be carried through. Yeah. In fact, that would be great. That'd be a great idea. All right, but we can do the dissolve second after we calculate this up. So We've got our negative ones, but we need to first calculate that new field. What's the new field going to be called? Let's keep it consistent. I said roads, and didn't we use a factor score or something, or factor rating? Forgot whether they capitalized or not, but as long as it's consistent, let's make this a float again. Okay, so roads, factor rating, and make it a float. Say okay. And then we're going to select only the negative ones. There's so many of them on this one because this is the one that has the most features. So it might just be good to say select by attributes and say the name of that field was, risk, roads, factor rating, FID is less than 0. Yep, that worked. I'll leave that up for a second. So instead of selecting them manually this time, because there's so many of them, I did it now.
It's selected the other way.
What's that?
Selection.
It's fine. So if it's selected the other way, then you, the negative one, actually, let's see what negative 1 means. Let's make sure that we're doing that right. Yep, negative 1 are the outside ones, it looks like. So they get the full values, actually. You just did it wrong. Half value. Okay, you're right, they get the half values like it said. Thank you. All right, outside gets the half values. Okay, so if you selected the inside ones, then just all you have to do when you go over here is say factor rating. So I've got my intensity divided by 2 here, but if you've selected the opposite, don't say divided by 2. So now hit OK. Oh, I got all zeros, which means that I chose the wrong field. Okay, there are 2 terrestrial intensity fields. And so choose the one that actually has values in it. There we go. Okay, and then the next thing that I need to do is switch the selection and choose, yep. And now I need to do the full intensity, which all I need to do is delete the divided by 2. Yeah.
How does it deal with overlaps and intersections?
Yeah, so basically we're going to end up, right now we're going to end up just adding all of the, like if there was a road coming in this way and a road coming in this way, unless we do the dissolve, these roads, there's going to be an overlap, there's going to be 2 buffers right there. And we're going to get 2 values.
Okay.
Because we're going to have 2 polygons. So when we do the overall score, it's going to get a score for both. Yeah, and so we would want to modify that if we wanted to do a minimum or whatever. But for now, we're not going to worry. We're not going to worry about that. We're going to add those together. We're going to add additive facts, and I can show you how to do that later. All right, so we did those 2.
I've been calculating for like a minute now. Is that ever
Anybody
normal?
else's?
Okay. I keep coming up with zeros.
That does look like it's taking a little while.
Yeah.
This was calculating.
Okay, right click.
I just got 1 divided by 2.
Okay. Try deleting the underscore 1. And then the 1 as well. Got it.
But it does that, but it doesn't. I got a code on that.
The ones today, so we have.
What's going over there?
That's no idea. I'm sorry.
Yours is interesting.
It's like pretty.
Because that's definitely, go back over. That's half.
That's half.
Yeah.
But I don't have the 7.5, so I have to choose it.
You're choosing all negative ones right now?
I'm not just that.
Those are the areas that shouldn't be half, though, right? Those are the inside. The inside guys. So actually, these should not be half. Somehow those are the inside guys. And switch the selection. And these areas, we probably did something different somewhere along the way, but as long as these are the outside areas, so it works.
Okay.
Any advice for us?
Well, it's moving, right?
Yeah, oh, definitely. I'll just keep going.
It's weird that it's taking so long.
Yeah, I wonder if I get it.
Oh, you don't have anything selected?
I do. I know a lot. They're all the negative ones.
It says right here. Now, are you doing the half right now, or?
I have. I'll try it.
Oh, are you running off of this? Is your data on there, or no? It is on there? That's why it's taking so long.
Okay. All right, I'll try again.
The write speed to the portable drive is
Okay.
10 times as long. So
Yeah.
it won't matter for small operations, but for a really large operation, it'll matter. Okay, so pretend we've done this to every single layer. At this time, we would do the overall union to combine the factor ratings for this layer and the factor ratings for the what's the two that we did, the towns and the roads. And we do that combination through another union. Let me bring that up real quick. So there's not a whole lot of areas where these overlap, but there are some, like right in here. There's some roads and towns that overlap. When we do this union, we'll have some overlapping areas in here. Not right now, but we're going to have to do the dissolve on the final product. But what we're doing, by not doing the dissolve on the roads, what we're doing is basically allowing the roads to multiply the intersection effect. And so in a normal area like this, that's selection, clear selection, features. Like this area, I'm hitting a road or I'm not hitting a road. Well, I'm outside. But in these areas where they join up, it's kind of like I've already done an intersection, because if I select this area right here, I'm hitting two different road features. Okay, one has a risk factor of 2 and the 2.5, and the other one has a risk factor of It's hard to click on it. Anyway, I don't know why it's not letting me. But the features don't have names there. Maybe. But there are two features there. You can see how there's 1, 2 right there. There's two features at that point. If I click right here, there'll be like a bunch of features because of all the intersections that are taking place. This one has 1, 2, 3. Because there's basically 3 pieces that are overlapping that area. There's this road coming in this way, there's this road coming in this way, and there's this road coming in this way. And the intersection of all 3 of those roads exists in this space right here. And that polygon right there, there are 3 roads that touch each other, and you have the effects of all 3 of those roads. So the way we're saying that is, within that polygon, you're going to have the effect of all 3 of those roads. Within this polygon, you're going to have the effect of all 3 of these roads. Same, but it'll be different because what's the difference between these 3 roads and these 3 roads right there? Right, there's a half distance. It's half for all 3, right? This one though, this area right here is half intensity for which road would that? Because it would be this one, but this road terminates right here. So this area right here gets half for the road coming in, and it gets the full intensity for these 2 roads. Okay. And then this area here is going to get the full from this one, the full from this one, and half again from this one. I guess this one does not have half from this one. Anyway, it doesn't really matter. They'll have the attributes from the ones that they, what's nice is the ArcGIS will keep track of all this. So yeah, this area right here would be half from this one, the full from this one, and half from this one. This area right here is, see how the full area, but.
That'll be full area as well.
Because the end of this road right here is right there. So this is the only full for that. This area would be full from all 3. This triangle, almost triangle right here, is full, half. Okay, this one is a full, half. So it's a half, you're right, half, full. Anyway. But they're all going to have those. So when I click it, there'll be 3 polygons there, and this one will have half intensity full. All right. All right. So yeah. So in order to do the final overlay, we're going to take our factor rating score and our towns factor rating score and our roads factor rating score and union those 2 together. So if I go under our toolbox and I go under union again. Choose the roads factor rating and the towns factor rating. So I have both of those factor ratings, and for now I'm going to call this overall factor rating, but it won't be. I'll just call it temp all. So it's not really the all, but it's all. All right. Actually, spatial join is probably going to be a better tool even than Dissolve for doing the combining. But we'll, yeah, I'm pretty sure it will be. Okay, so I'm going to hit OK here, and it's going to run through. And it's going to take a little while, evidently. it's doing a lot of calculations. So now I have this layer. I didn't really need to zoom out. I'll zoom back in. What's this pink? Small scale ag. Okay. All right, so now I have my risk towns buffer right here. Where does it zoom to layer? I might have messed up because I still see, oh, sorry. There we go. The temp all factor is what I want. I didn't mess up. So that's the layer I want. And now there are just a bunch of values stored in this data set. If I open up the attribute table, I have a bunch of fields, but I have my 2 fields that I'm concerned about. My town rating. I just tell them how a 0 in town rating. Right, they're only on a road. I have my road rating. Okay, my road rating over here, 7.5. Okay. I have my road rating and my town rating. And I want an overall rating. I could take my roads factor rating and my towns factor rating and add them up and get an overall rating. So I can add a new field and call this overall rating. I'm gonna make it a float. And then add roads factor rating and town rating. I guess I called them, and add those together. Now we're just going to do a simple adding them together. If I wanted to multiply them by their weights, I could. One would have this weight underscore 1. Oh, would have the weight, but we're not going to. They're all 1s. So if we multiply something by 1, what does it equal? Itself. So if all the weights are 1, there's no reason to do that. But this formula here, with each individual rating, is the one, basically the one from the lecture, modified slightly, because the ones from the lecture had each rating multiplied by its weight added together. All right, calculate that. And now I have a value, and I could symbolize on that value. I can say properties and symbology, and choose the overall factor or the overall rating, and I get values that look like that. You can see where the higher ratings exist because they're inside of a town.
Maximum sample size is not already.
You just hit OK, and what it does is it doesn't use every single record to find what the high and low values are. Yeah, so. So that's under quantities, graduated covers, colors, overall rating.
Your top end score is like 155.
Yeah.
I think.
What's your top end score?
125. I just messed something up in the math.
Perhaps.
Yeah, it's just something.
Is your top start time?
The wind turns at 2.5. And I don't know.
That's not gonna work. All right. Okay, so there's one more step that technically we need to do, because sometimes there's still these overlapping features. Okay, so I'm gonna put that off till next week though. So what you need to do is do all of what we've done so far for each of the individuals. You can put off calculating the overall rating score until next week. So calculate up the, remember everything's due 2 weeks after it's assigned. Calculate up what the risk rating for each of the layers. For each of the risk layers. Does everybody understand that? And then we'll go through the rest of it, because it still seems like we're not getting all of these consistently right. So let's focus on that. I'm going to be around for the next 45 minutes to make sure that everybody's values are correct. There is Heather there yet on that end? Awesome. Great. All right.
What's
that?
What is the risk of what?
So, well, yeah, so the risk of what? This is basically it's a value that was basically determined by people, and it's a negative factor for preserving. It's a risk to the habitats. Habitat risk. Habitat risk is what it is. So the higher the number, the more risk there is to a local habitat. And so what we're trying to get to is an area that has the overall lowest risk. To not get your math? Oh, what are all these red things?
That's the higher.
Okay.
But I don't have those.
That looks right.
I don't have like the landmass.
Oh, that's it's watershed.
That's whenever I was practically know that.
Yeah.
Blocked out some of the other attributes.
125 is your highest.
My highest.
Yeah. I wonder if that's some process of the way it was run, but anyway, sorry. What's
They said whenever I checked, when all of them's checked, it finds out some of them.
right? And that's not a problem.
Okay.
That's just the order that you can move these around. So the only real issue is the numbers are slightly different somehow. Are yours both 125?
Yes. I was 89.
It may have been
Oh, sorry, what was the low? Low is still 2.5.
125. 8.5, yeah.
All right, hey, I got a better idea. So Okay, so Heather, you can listen to this too. So up here, for this overall rating, some people are getting a different score, right? Let's not worry about that right now, because what that means is that the overall score is not calculated correctly, but it could be because the underlying factors weren't calculated correctly, or it's because you didn't do the final step the right way. And we're gonna redo the final step next week. Okay, so if that's the reason, it's no problem. However, what we should do is look at, I'm gonna turn this off for now. Look at the factor ratings for the individual scores and symbolize those guys. I'll symbolize those by roads. And so mine go from 2.5 to 60, and from, there's the buffer, the towns, and those go from 2.5 to 95. Okay, so those are the values that I have. How did it? Maybe those are different. Check those. What are yours?
The lowest is still 2.5, and the highest is
15 for which one?
the roads factor rating.
The roads factor rating. So you have the highest is 15?
Mine's 30.
Okay. You guys are the 30 down there. What about the town rating?
Highest. No.
Nice.
95, that's what I have.
My lowest is 0.
Your lowest is 0?
No.
Yeah, so let me look at my individual values here. So this is for roads. If yours matches mine, then you're good. So for roads, my lowest is 2.5 and my highest is 60. For towns, they range from 2.5 to 95. So
My highest roads is 30. Yeah, my highest roads. Is your highest road 30?
highest road was 30. Okay, so let's look. I mean, I'm pretty sure that mine is correct, but let's make sure. If we go to roads and we look, the highest road should be the same as the highest intensity. Oh, it's 30. So I messed up. It's my fault. One of you guys probably did it right. So if 30 is your highest value, you did it right. So I probably chose the distance. Distance is never 90. Wait, this is roads, right? Oh, sorry. My highest is 60. So yeah, I probably accidentally chose distance once as the value to use instead of intensity. That's why my numbers were wrong. Okay. All right. Okay, so I'm gonna just recalculate that really quick, because that was the very last step. It's not like I have to do any overlays again. All I have to do to create that is go back under the roads factor rating score, open that attribute table, and select by attributes. Oops. Say okay. And then now for roads factor, if it's -1, it's the ones outside. So those are the ones I want to half. Field calculator, and I take the intensity. So I must have taken the distance and halved it. So intensity. So what's the other one? Remember, there's two intensity fields. _1 Run it again. Okay. And then I switch to selection. Field calculator. And instead of intensity divided by 2, I just take the raw intensity, say okay. And now, if I recalculate this, yep, the highest is now 30. Okay. All right. Great. So don't worry about the overall score yet. Just do the factor rating for each individual one, and then we'll join them together at the end. You could actually get as far as unioning all the results, but there's one more step after that. But we'll still do the union together. All right, so I've got my my roads factor rating and my towns factor rating. And let's just check to see if I look at towns, the original towns scores. The largest one should be 95. If they're not, then I messed up on that one too. But 5 to 95. Yep. So the highest one should be, the lowest one should be 2.5 because that's half of 5, and the highest one should be 95. So I did that one right. I was the one that messed up on the first one. So yeah, go through, for next week, go through each of these, and I can practice, basically, I should have written those steps down, but the steps were, take the half intensity field, then do a buffer, and union those two buffers, and then calculate the final factor intensity. And if you actually go back and watch the video, you can see where I messed up and everything. To find out where I put in distance instead of intensity. So now, if anybody ever watches the video, I'll have to wait till the end to figure out that. Hopefully they'll catch it. All right. All right. So yeah, if you want to do those right now, you're free to do it. If you want to do it later, you can do it later. But just do that part of it before next week. Any other question? All right, we're right back. I'm just gonna.
Oh my god. No, I don't think I can't like it either. I don't know how to. I don't want it to that piece. None of my things are that color. I have to read it. Before we start, now we're gonna start.
I still know.
It would be much smarter, right? Instead of, maybe much operations, the exact same thing. That would be too easy. Until story, I guess, that's parts of you. But we need to do conservations. Just do the same thing over and over and over again. Well, see, you have a one-on-one computer talk. You make it understand what is out there right now. Exactly. As a teacher. You really want to feel always okay, what I can do is better for you. What are you going to do?
We'll see you on the
Now I have to do something. I pressed it already. But your first time wasn't it? Not. The first time that we create like yeah, here it wasn't the occasion was terrorist correct. Yes. Resolutions. Yeah. That gives you your like. I already have numbers. Well, that gives you your like inner circle and your outer circle. Yeah. That makes sense. Oh, logic. Okay. I've been reading. I was like, oh, there's little Sarah's baby. Oh my god. How would you? Okay, so that's fine. Yeah. Going really fast. Yeah. Better upper half, this is better half. Oh my gosh. Feel half disto. Oh, we changed this. Change it to half disto. Oh my god. Oh, you could just add on. I took a shortcut this time. Half disto. What did you do now? We're good. Okay. Okay, now we're union. Unique values. Stories. Stories.
All right, anybody have any questions as you're working through it? I do have to leave without my phone. They asked me questions through the idea. He would have heard.
So cool. Something happened. That's really intense. Union check. My little check. Like, it's done. Stop allergies. You try to. Down here. Here's your pink. Mine are blue. Yeah, blue. Yeah, I like that. Your hard drive. Oh, it's all linked to the hard drive. That's what shows you. Oh my God.
Because I had some.
I was like, how do you do that?
So I did this.
Okay.
Right. With help.
I maybe tried school 2010, went 2011, but you're oh my God, 2005.
Really
8 years old. Oh my God, where'd you have from? I was and I love it.
This is the piece I have.
But I haven't done no idea what except for her.
Yeah.
Miami? I thought it was. Our kids were always really awful. Actually, my senior prom was aspiration. That was a really cool thing to go. What I remember. And then one else we got from Union. Now we're finding all smaller area intensities. I think all